Hello everyone. So this is the second hour of current electricity and personally it's my favorite hour. Why? Because here we will learn how to solve circuits. Now, before we start solving circuits, we need to understand something called KVL, Kirchhoff's voltage law. And personally, I never ever use KVL. I will teach you one smaller method to solve the circuit questions easily. So without wasting time, let's start learning the second hour where we will have a lot of fun for sure. So first of all, what is KVL? Kirchhoff's voltage law says that the net potential drop across a closed loop is zero. The net potential drop across a closed loop is zero. It means that you start at a point in the circuit, you move around the circuit, you come back to the same point, and there will be no net potential drop. Isn't this quite an obvious statement that if you have a circuit and you start from a point and you come back to the same point, on reaching the same point again, you will find the same potential. So if I start from this point X, I go one around the loop and come back to the same point, I will find the same potential. Hence, the net potential drop in a closed loop is zero. This is what KVL says. Now, what is KVL based on? We have learned that KCL is based on principle of conservation of charge. Similarly, KVL is based on principle of conservation of energy. So without wasting time, let's learn how to apply KVL. Let's say we have got this type of circuit. We have got resistance of 3 ohm, battery of 2 volt, resistance of 6 ohm, 2 ohm, 12 volt, 9 ohm, and so on. Now, the statement says that the net potential drop across a closed loop is zero. But I don't know what is the current in this circuit. Using KVL, I can find out the current in this loop. There are easier method, better method. We will learn all of them where you will never have to use KVL. But let's say we assume that in this circuit there is a clockwise current I. So assume that there is a clockwise current in this whole circuit and this clockwise current is I. Start from any point in the circuit. Let's say we have chosen this point as X and we go once around the loop and come back to the same point. If we go once around the loop and come back to the same point, the statement of KVL says that the net potential drop in a closed loop is zero. So start from here, go clockwise once around the loop and come back to the same point and write the potential of this point. How to do it? See, if the potential of this point is X, can you tell me what will be the potential of this point? Sir, here we have got a battery of 2 volt. If we have got a battery of 2 volt, it means that the positive plate of the battery will be at a potential 2 volt higher than the negative plate. Hence, the potential of this point has to be X plus 2. Since the negative plate has a potential of X, the positive plate will have a potential of 2 volt higher, so X plus 2. Now, we can see we have assumed that there is a clockwise current in the circuit. So, since there is a clockwise current in the circuit, we know that in a resistor, current flows from higher potential to lower potential. Since the current is going up, it means that the point above the 3 ohm will be at a lower potential compared to point below it. Now, how much will be the potential drop across this 3 volt? So, you will say, sir, from Ohm's law, delta V equals to IR. If the resistance is 3 ohm and we have assumed a current I, then the potential drop has to be equals to I into 3. So the potential of this point will be X plus 2 minus 3I. Now we have assumed a current I clockwise. Can you tell me what will be the potential of this point? Sir, the point on the left will be at higher potential than the point on the right because in this 6 ohm resistance, current is going from left to right. How much is the potential drop across the 6 ohm? So sir, from IR, 6 into I. So the point on the right will have a potential of X plus 2 minus 3I minus 6I. Similarly, if I ask you what is the potential of this point, again you will say, sir, in this one current is going downward. So the lower point will have a potential less. How much less? Equal to the potential drop across the resistor, and that will be 2 ohm into I, 2I. So here at this point potential will be X plus 2 minus 3I minus 6I minus 2I. What will be the potential of this point? You are going from positive terminal of the battery to its negative terminal, right? If you are going from positive terminal of the battery to its negative terminal and the battery is of 12 volt, it means that the negative terminal will have a potential 12 volt lesser. So if the potential of the upper point is X plus 2 minus 3I minus 6I minus 2I, then the potential of this lower point will be X plus 2 minus 3I minus 6I minus 2I minus 12. Now go back to the same point X. So as to go back to the same point X via this 9 ohm resistor, again you will say in this 9 ohm resistor current is going from right to left. If the current is going from right to left, it means that the point on the left must have a lower potential. How much lower? I into R, 9I lower. So again, you will come back to the same point and say the potential of this point has to be x plus 2 minus 3I minus 6I minus 2I minus 12. That is the potential on its right, minus 9I. And now you are back at the same point. So as the net potential drop in the closed loop has to be 0, this point will again have the same potential x. And you can solve this equation to find I, and that's how you apply KVL. Personally, I am again saying you will never ever apply KVL, but you need to know how to apply it, because sometimes the pure question comes on applying KVL. That's why you should know how to apply it, and it's very easy. So you will say potentially here is x plus 2 minus 3I minus 6I minus 2I minus 12 minus 9I, and this has to be equal to x. Once you have written this, you can cancel out x and x on both the sides. Now here you have got 3I, 6I, 2I, 9I. 3 plus 6, 9, 9 plus 2, 11, 11 plus 9, 20. So you will get on the right hand side 20I, and on the left hand side you will be left with 2, and there is a minus 12, so minus 10 equals to 20I. You can check it back. So on solving this, you get current equals to minus 0.5 ampere. Once you get the current to be minus 0.5, what does this minus sign tells you? The same thing it tells everywhere in physics, that the direction of current you have chosen is wrong. Current is actually in this circuit anti-clockwise, while you assumed at the beginning of solving that the current is clockwise. Since you assumed it to be clockwise, you got a negative answer which tells you that current is actually anti-clockwise. Okay, so this is an example. How do we apply KVL? What does KVL tells us, and from where it comes? KVL tells us that the net potential drop across a closed loop is 0. It comes from principle of conservation of energy, and this is how you apply KVL. By the way, again saying, repeating myself, we are not going to apply it at all. So the negative sign here tells us that the direction of current chosen is wrong. So let's first talk about the series and parallel combination of the resistors before we move on to solving circuit question. So if you have got multiple resistors in series, and let's say these resistors are R1, R2 and R3. When you have got resistors in series, same current flow through them. When you have got resistors in series, same current flow through all of them. And we say that, let's say the potential drop across the first resistor is delta V1, the potential drop across the second resistor is delta V2, and the potential drop across the third resistor is delta V3. So I can say that delta V1 has to be nothing but I into R1. Similarly, बच्चों, delta V2 has to be equals to I into R2, and delta V3 has to be equals to I into R3. Now, you can say that when connected in series, the potential drop across a resistor is directly proportional to its resistance, because the current flowing through all of them have to be same. So if let's say tomorrow you find two resistors of 3 ohm and 6 ohm connected in series, I know that since they are connected in series, the current flowing through both of them have to be same. But since the second resistor is double that of first resistance, that's why it will always have double the potential drop compared to first one. Why? Because the current is same, and we know that potential drop has to be current times resistance. Since the resistance of second one is double, it will always have double the potential drop compared to first one. So keep this thing in mind. When you have got resistors in series, then the potential drop across any resistance is directly proportional to its resistance, right? It's obvious. Moving on. Replacing all these three resistors, I can place a single resistor. And for that single resistor, the value of equivalent resistance has to be nothing but R1 plus R2 plus R3 and so on. So this is how simple are the points that you need to remember for resistors in series. Now moving on, if you have got resistors in parallel, when the resistors are connected in parallel, they have got same potential drop across them. All of them are connected in parallel. So let's say potential of all the points on the left is X, 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 and potential of all the points on the right hand side is Y, 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 Y. Since all of them are connected across the same potential drop, we say that they are in parallel. So when resistors are in parallel, they are placed across the same potential drop. This is something important. Now, you can say that the potential drop across first resistor has to be I1 into R1. Yes, sir. The potential drop across second resistor has to be I2 into R2. Across third resistor has to be I3 into R3, right? So you can say that I1 R1 equals to I2 R2 equals to I3 R3 because these are the potential drops across each resistors, and when the resistors are connected in parallel, the potential drop across them have to be seen. Now, let's say this potential drop is delta V. Okay, sir. So from here, we can say that when resistors are connected in parallel, the potential drop across them comes out to be same. Now, we can say that the current entering into the parallel combination has to be equals to sum of current in each individual branch. So I has to be equals to I1 plus I2 plus I3 and so on, right? And we can say that the current in each particular resistor is inversely proportional to its resistance. Sir, how can you say? Can I say that I1 equals to delta V by R1? Yes, sir. Can I say that I2 has to be equals to the potential drop across the parallel combination by R2? And I can say that I3 equals to delta V by R3 and so on, right? Since the potential drop across each resistor is same, I can say that the current flowing through each resistor is inversely proportional to its resistance. So if you have got two resistors connected in parallel, and let's say these are resistors of 3 ohm and 6 ohm. Since I know that they are connected in parallel, they have to have the same potential drop. That's why the current flowing through 6 ohm must be half of that of 3 ohm. So if the current flowing through 3 ohm is I, then the current flowing through 6 ohm has to be I by 2. Isn't this obvious? And when we try to find the R equivalent, we say that 1 upon R equivalent for this parallel combination equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So 1 upon R equivalent. If you wish to replace all these resistors in parallel and place a single resistor, then to find the equivalent resistance of all these, you say that we can use the formula 1 upon R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. And I know that you know this formula by heart. So now one important case. If you have got two resistances R1 and R2 in parallel and a current I flows through their combination, then how to find the current flowing through each resistor? Now see kids, I am telling you the standard method how to do it, and you need to remember the result because it is very useful in solving many questions quickly. So you will say if you have got two resistors in parallel, then using the parallel combination, I can find out their equivalent resistance. I will say that 1 upon R equivalent equals to 1 by R1 plus 1 by R2. That gives me R2 plus R1 upon R1 R2. And then flipping both the sides, I get that R equivalent comes out to be equals to R1 R2 by R1 plus R2. I will never ever do this again. Whenever you have got two resistances in parallel and they have got resistance of R1 and R2, you need to remember that R equivalent comes out to be R1 R2 upon R1 plus R2. R equivalent comes out to be R1 R2 upon R1 plus R2. Now बच्चों, if the current through the combination is I and their equivalent resistance is R1 R2 upon R1 plus R2, then you can say that the potential drop across the combination has to be equal to the current through the combination multiplied by its equivalent resistance, which is R1 R2 upon R1 plus R2. So question is, what will be the current flowing through R1? We know the potential drop across R1. If I divide this potential drop with the first resistance, I will get the current flowing through it. So the current flowing through R1 has to be I into R2 upon R1 plus R2. And similarly, to find the current through the second resistance, I can say that it has to be equal to the potential drop across the second resistance divided by R2. So divide this time with R2 so you don't get R2 and you get I into R1 upon R1 plus R2. You need to remember this result by heart. The current through the upper resistance R1 is I into R2 by R1 plus R2, and the current through the second resistor R2 is I into R1 upon R1 plus R2. Now let's do some important points about series and parallel combination of resistors before we move on to the fun part of not applying KVL. So the first point goes like, if n identical resistors, each of resistance R, are connected, if n identical resistors, each of resistance R are connected in series, then what will be the R equivalent? So think that you have got n identical resistors, each of resistance R connected in series. So each one of them have resistance R, so on. So you will say that the R equivalent will be nothing but R plus R plus R plus R plus R. How many times? N times. So the R equivalent will be nothing but N into R. Similarly, if you have got all these resistors connected in parallel, R in parallel, Then what will be the equivalent resistance? So you will say 1 by R equivalent equals to 1 by R plus 1 by R plus 1 by R plus 1 by R. How many times? N times. So you will get 1 upon R equivalent equals to N times 1 by R. That becomes N by R. Now flipping both the sides, you will get that R equivalent equals to R by N. So if connected in parallel, R equivalent equals to R by N. What I tell here, kids, is there is one more way to visualize this. You know that for a single resistor of length L and cross-sectional area A, the resistance comes out to be rho L by A. Now, if you connect multiple identical rods in series, so you are effectively making the length n times. If you make the length n times, the numerator becomes n times, the resistance becomes n times. And when you connect multiple such identical rods in parallel, so the length of combination remains the same, but the cross-sectional area available for flow of current, if you connect them in parallel, the cross-sectional area available for flow of current, that becomes n times. That's why the denominator becomes n times, so the resistance becomes 1 by n times. So just remember, when you have got n identical resistors connected in series, equivalent resistance becomes nr. When n identical resistors are connected in parallel, the equivalent resistance becomes r by n. So if tomorrow they give you 3 identical resistors of 6 ohm connected in parallel, so the equivalent resistance will be 6 by 3, that will be 2 ohm. That's what this idea means. So moving on, if two resistors are connected in parallel, if you have got these two resistors connected in parallel, better don't use every time 1 upon R equivalent equals to 1 by R1 plus 1 by R2. What I am telling you here is just a time saving method. Rather than using 1 upon R equivalent equals to 1 by R1 plus 1 by R2, use that R equivalent is R1 R2 upon R1 plus R2, which we have just done in the last slide. Moving on to the third point. If multiple resistors are connected in series, then the equivalent resistance is higher than all of them. It means that, let's say you have placed 3 resistances in series, 6 ohm, 3 ohm, 2 ohm. What will be the equivalent resistance? So 6 plus 3 plus 2, simply add them up. So that will be 11 ohm. So what I am saying is, when you connect multiple resistors in series, the equivalent resistance comes out to be more than any one of them. So it is more than 6, it is more than 3, it is more than 2. And isn't this obvious? So if multiple resistors are connected in series, the equivalent resistance is higher than all of them. This is something you should know. Next point, if multiple resistors are connected in parallel, the equivalent resistance is less than the least of them. So what I am saying, if you have got multiple resistors of, let's say, like 1000 ohm, 10 ohm, 1 ohm, when you find out the equivalent resistance of these three, it will come out to be even less than 1 ohm. It will come out to be lesser than the least of the lot. So I can say with 100% guarantee that the R equivalent of this whole combination has to be less than the least one of them. It will be even less than 1 ohm. Sir, are you sure? I am sure. You can do the calculation. You can take 1 upon R equivalent equals to 1 by 1000 plus 1 by 10 plus 1 by 1 and check it out. And my basic argument is, when you are connecting multiple resistances in parallel, what you are doing, you are increasing the cross-sectional area available for the flow of current. If you are increasing the cross-sectional area available for flow of current, the equivalent resistance has to be less than each one of them. That's what it means. So if multiple resistors are connected in parallel, then equivalent resistance is less than least of them all. So these are some important points that you should know. So now the fun begins. Current in a loop. Let's say they have given me this type of loop, and in this loop you can see there are 3 batteries, 8 volt, 4 volt, 12 volt, and there are multiple resistors in the loop, 1 ohm, 2 ohm, 3 ohm, 2 ohm, right? Now we need to first focus on the polarity of the batteries. Polarity of the battery is really important thing, and if you can get this, you will be able to answer every question quickly. So what do I mean when I say polarity of the battery? In which sense a given battery wishes to drive the current? So you will say here the 8 volt wishes to drive current from its positive plate towards its negative plate. And in doing so, in the loop, it will have to drive a current clockwise. Will it be able to? That's a question depending on its strength. Now, forget everything else and just focus on this 4 volt. This 4-volt battery will try to drive a current from its positive plate towards its negative plate. So in the loop, it will try to drive an anti-clockwise current. Now let's think of the 12-volt battery. It will also try to drive a current from its positive plate towards its negative plate, and in the process, in the loop, it will try to drive an anti-clockwise current. So 8-volt wishes to drive clockwise, 4-volt wishes to drive anti-clockwise, 12-volt wishes to drive anti-clockwise. Tell me who wins? Sir, definitely anti-clockwise wins. Why? Because there is more EMF, stronger batteries which wish to drive the current anti-clockwise. Now, if I ask you what is the net EMF which is trying to drive the current anti-clockwise, so you will say, sir, 12 and 4 are in team anti-clockwise while 8 is in team clockwise. So the net EMF in anti-clockwise sense will be 12 plus 4, the one which wish to drive the current anti-clockwise, minus 8 volt, the one which wishes to drive the current clockwise. So the effective EMF is 8 volt which wishes to drive the current anti-clockwise. Now, once we know what is the EMF of the loop, we need to now know what is the resistance in the loop. Now, I should treat all these resistances to be in series or parallel. So, since same current flows through all of them, they should be treated in series. And in series, you can directly add up the resistances. So, you will say the resistance of the circuit will be 1 ohm plus 2 ohm plus 3 ohm plus 2 ohm. 1 plus 2 plus 3 plus 2, that gives you 4 plus 4, 8 ohm. So the equivalent EMF which is trying to drive the current in the loop is 8 volt and the equivalent resistance is 8 ohm. So what has to be the current? So current has to be equal to the potential drop upon the resistance. The potential drop net is 8 volt and the resistance is 8, so you get 1 ampere. Which sense? Anti-clockwise. So that is the answer. Current in this loop is 1 ampere anti-clockwise. Now I am showing you the next figure. Without raising pen, pause the video and try to get the answer before I give it to you. Okay, so let's start. You will say this 4 volt want to drive clockwise, this 12 volt want to drive clockwise, this 8 volt want to drive clockwise from its positive to its negative, and this 4 volt want to drive anti-clockwise. So in the team clockwise, we have got 4, 12 and 8, and in the team anti-clockwise, we have got 4. And you need to do all these things in your mind. Now, these two 4 and 4 will cancel out each other's effect. So the net EMF trying to drive the current in the clockwise sense is 12 plus 8, that is 20 volt of clockwise EMF. The equivalent to resistance is 6 plus 4 plus 8 plus 2. 6 plus 4 plus 8 plus 2, that is 10 plus 10, that is 20. So 20 ohm is the equivalent resistance. 20 volt is the equivalent EMF trying to drive the current clockwise. So the current in the circuit has to be potential drop upon resistance, that will be 1 ampere clockwise. Let's see the next example. Pause the video, get your answer, and then look at the answer. So you will say this 6 volt want to drive current clockwise, this 4 volt want to drive current anti-clockwise, this 8 volt want to drive current clockwise, this 6 volt want to drive current clockwise. Do all these things in your mind. So you will say the net EMF which is trying to drive the current clockwise is 8 plus 6 plus 6 minus 4. Now 8 plus 6 plus 6 gives you 20, minus 4 gives you 16. So the net EMF trying to drive the current clockwise is 16. And the equivalent resistance of this circuit is 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. So the equivalent resistance is 8. So the current has to be equals to 16 by 8, which is 2 ampere clockwise. Did you get the right answer? If not, do not worry, practice the next one. Pause the video, get your answer before I solve it. So now, you will say, in this circuit, 8 volt want to drive the current clockwise, while the 6 volt also want to drive the current clockwise. So both of them are supporting. So the equivalent EMF trying to drive the current in the circuit is 8 volt plus 6 volt, that is 14 volt. And the equivalent resistance is 1 plus 3, 4 plus 1, 5, 5 plus 2, 7. So the current has to be 14 by 7, that is 2 ampere. In which sense? In the sense the batteries want to drive the current which is clockwise. So you get 2 ampere clockwise. Okay. They won't ask you simple question like determine the current in a single loop. They will tweak the question little bit and ask you a question like this: find VA minus VB. Here you can see that there is a single loop, but you need to find the potential difference between A and B. So first of all, to find the potential difference between A and B, you need to identify what is the current in this loop. So you will say this 3 volt tries to drive current from its positive to negative, so clockwise. This 2 volt tries to drive current from its positive to negative, clockwise. This 6 volt tries to drive current from its positive to negative, again clockwise. So all the 3 batteries are trying to drive the current in the same sense. So the equivalent EMF of this system, which is trying to drive the current clockwise, is 3 plus 2 plus 6, that comes out to be 11 volt clockwise. Now what is the equivalent resistance? Since same current flows through all the resistors, all of them are in series. So the equivalent resistance will be 2 plus 1 3, 3 plus 2 5, 5 plus 6 11 ohm. And when you find things like 11 volt and 11 ohm, you can think that okay, I am doing something right. So the current in the loop comes out to be the equivalent EMF 11 upon the equivalent resistance 11. So that comes out to be 1 ampere clockwise. So we have identified that the current in this loop is going to be 1 ampere clockwise. But that's not our mission to find. Our mission is to find VA minus VB. So as to find the potential difference between point A and B, I tell students to go from point A to B while writing potential drop across each thing they find on the path. So you can go from A to B via the upper line or via the lower line. So let's go from A to B via the upper line. So going from A to B via the upper line, you will say the potential of this point is VA. Yeah. The potential of this point above 3 volt will be 3 volt higher than the point below it. Why? Because here we have a battery of 3 volt. The job of this battery is to create a potential difference of 3 volt. So we can say the potential at this point has to be 3 volt higher than the potential at A. Hence the potential at this point has to be VA plus 3. Now tell me, if I keep on moving up, this new point will have a higher potential than the point below or lower. Since in the loop current is clockwise, in this 2 ohm resistance current is going up. So the upper point must be at lower potential. In the resistance, current flows from higher potential to lower potential. Now this upper point will have a lower potential. How much lower? So you will say it will have a lower potential equals to I into R. Current is 1, resistance is 2. So this point will have a potential VA plus 3 minus 2. Now let's jump across this 1 ohm. If I go from the left of 1 ohm to the right of 1 ohm, I know that since in the loop current is clockwise, in this 1 ohm current is from left to right. Since in this 1 ohm current is from left to right, the point on the right will have a lower potential. How much lower? The current flowing through it into its resistance, that is 1 volt. So the point on the right will have a potential VA plus 3 minus 2 minus 1. And then jumping from this point to B, again because of the battery of 2 volt, the potential will increase by 2. So plus 2, and this has to be the potential of point B. So you can say that VA plus 3 minus 2 minus 1 plus 2 equals to VB. I know that many of you find problem when I jump across the resistor. Have faith, I have done it right, and try to do it on your own and think over it. Why he has written minus? Why not plus? So going from A to B via the upper line, I can make the equation VA plus 3 minus 2 minus 1 plus 2 equals to VB. Hence, this 3 minus 2 minus 1 get cancelled. So you get VA minus VB equals to minus 2 volt. You will get the same answer if you go from A to B via the lower line. Try to do that as well, and you should get the same answer, that VA minus VB equals to minus 2 volt. Now let's see the next example. Determine the current in the following circuit. So there is a simple circuit given to us, and we need to determine what is the current in this circuit. So you will say this 10 volt tries to drive current from its positive plate to negative plate, that is anti-clockwise, while this 5 volt tries to drive current from its positive plate to its negative plate, so in the loop clockwise. Who wins? So definitely 10 volt battery, stronger battery, it will win. So the equivalent EMF which is trying to drive current in this circuit is 10 volt clockwise minus 5 volt anti-clockwise. So you get an overall equivalent EMF of 5 volt clockwise. Now what will be the current in the loop? You will say that the equivalent resistance will be 2 plus 3, which is 5. So the current in the loop comes out to be 5 by 5, which is 1 ampere, in the sense of the way 10 volt want to drive, which is anti-clockwise. So we can say that the current in this loop has to be 1 ampere anticlockwise. Such a simple question. Now we can write the equation of KVL to get the same thing. We have got here the equation of KVL written. Verify it. I have started from this point, let's say X, taken the current I anticlockwise and written X minus 2I plus 10 minus 5 minus 3I equals to X, and have cancelled out X both the sides, so I get minus 2I plus 10 minus 5 minus 3I equals to 0. On solving this, you get I equals to 1 ampere. And this current of 1 ampere is anticlockwise. I will like to here tell you a little bit more about this question. They might ask you, out of these two cells, one of them is getting charged while one of them is getting discharged. So which one is getting discharged and which one is getting charged? So you will say, since the current leaves the positive terminal of 10 volt and enters the negative terminal, the 10 volt is getting discharged, while the current enters the positive terminal of 5 volt and exits the negative terminal, the way in which our batteries do not work usually. So the 5 volt battery is getting charged. They might even ask you, what is the potential difference across these 2 points, let's say X and Y. So if this point is at potential X, this point will also be at X. If this point is at potential Y, this point will also be at Y. So you can find the potential difference between X and Y either looking at the upper battery or at the lower battery. You can say that since the upper battery is discharging, and we know that when a battery gets discharged, the potential drop across it is E minus IR. The EMF of the battery in the upper line is 10, current is 1, and the resistance is 2, so you get 8 volt. Or you can do the same thing but for the lower battery. You will say that the lower battery is getting charged, and when a battery gets charged, the potential drop across its terminal is E plus IR. Here the EMF is 5, current is 1, and the resistance is 3. So you get the same thing, 8 volt, right? Because Vx minus Vy has to be constant, and in this case Vx minus Vy comes out to be 8 volt in both the cases. Let's see one more simple numerical. So this is the circuit, and they're asking you, in the following circuit, the potential difference between P and Q is. So what is the potential difference between P and Q? So you will say, sir, how to solve this circuit? See, here in the circuit, you will find 2 points which are connected to earth. Yes, if 2 points are connected to earth, their potential has to be 0. So the potential of this point is 0 as well as potential of this point is 0. Now we know that all the points directly connected by a wire are at same potential. So since both the points are at same potential, we can assume that they are connected by a wire. So now this becomes a loop question. So rather than thinking of 2 points grounded, think of 2 points which are connected by a wire, and your circuit looks something like this. There is a battery of 15 volt, join the 2 grounded points, and you have got resistance of 5 ohm, and there is a resistance R, and in the question they have given you 2 ampere of anticlockwise current. Since the current is anti-clockwise, through this resistance the current goes from right to left, so I know that the point on the right, Q, is at higher potential than the point on the P. And I can say that potential at Q minus potential at P has to be equal to the resistance times the current, which is R into 2. But how to find R? Easy. You will say that in this whole single loop, the EMF which is trying to drive the current is of this 15 volt battery. And the equivalent resistance of the circuit will be 5 plus R, because both of them are in series. So you will say the current, which is 2, has to be equals to equivalent EMF upon the resistance, which is 5 plus R. So what you get from here is 10 plus 2R equals to 15, or 2R equals to 5, or the resistance comes out to be 2.5 ohm. Once you know that resistance is 2.5 ohm, substituting it here, you will get Vp minus Vq, or Vq minus Vp, to be equals to 2.5 into 2, which is 5 volt. So this is one way to solve the question. Another way is to write the equation of KVL. Start from this point, go once around the loop, and reach this point where the potential is again 0. So you will say, by using KVL, I can write 0 minus 5 into 2 minus 2 into R plus 15 equals to 0. and 2 into R is the potential drop across Q and P. So you can say 2 into R equals to minus 10 plus 5, which is 5. So the potential drop between P and Q has to be 5 volt. So this can even be done by writing the equation of KVL. So now we will talk about something very important, which is the combination of cells. First, with the easy case, when the cells are in series. Let's say they have given you these multiple cells of EMF E1, E2, E3, E4 having internal resistance R1, R2, R3, R4. And you wish to replace all these cells with a single cell, then what has to be the EMF of that cell and what has to be the internal resistance? So you will say, since all the resistances are connected in series, the same current is bound to flow through them. The equivalent resistance will be nothing but R1 plus R2 plus R3 plus R4. But what about the equivalent EMF? This first battery wants the potential of the left hand side to be higher by E1, second battery wants the potential of left hand side to be higher by E2, the third battery wants the potential on the left hand side to be higher by E3, the fourth battery wants the potential on the left hand side to be higher by E4. So the net EMF comes out to be E1 plus E2 plus E3 plus E4, while the net equivalent resistance comes out to be R1 plus R2 plus R3 plus R4. And I think that you find it easy. But whenever batteries are concerned, I tell this to all the kids, be very cautious about the polarity of battery. In the question, they will flip the polarity of one of the batteries. Here you can see the first battery wants the potential of left hand side to be higher, second battery wants the potential of left hand side to be higher, while the third battery wants potential of right hand side to be higher. And if these three batteries have got EMF of E1, E2, E3 and internal resistance of R1, R2, R3, how to replace them with a single battery, what has to be its equivalent EMF and what has to be its equivalent resistance? So you will say the equivalent EMF will be written as E1 plus E2 minus E3, because E3 wants the right hand side to be at higher potential, while the equivalent resistance remains the same formula, since all of them are in series, same current flows through them, the R equivalent will be nothing but R1 plus R2 plus R3. So this is a simple case when you have got combination of cells in series. I am again saying be very cautious about the polarity of batteries. So let's practice a question based on this. So the question goes like, if n identical cells, each of EMF E and internal resistance R are connected to drive current in the same polarity sense. Here you can see this first battery wants current to go anti-clockwise, second battery wants current to go anti-clockwise, third battery wants current to go anti-clockwise. If all the cells are connected to form a loop and there are n cells, each cell having EMF of E and internal resistance R, and all of them tries to drive the current in the same sense, you need to find what will be the current in the loop. Second, what will be the potential drop across each cell? And third, current in the loop if polarity of X cells out of n cells, polarity of X cells is reversed. So let's do part by part. Since all the cells tries to drive the current in the same sense, you will say that the equivalent EMF will be equals to E plus E plus E plus E plus E plus E plus E. How many times? N times, so that will be NE. The equivalent resistance will be equals to R plus R plus R plus R plus R. How many times? N times, so you get NR. So the current in the loop has to be equivalent EMF divided by equivalent resistance. So the current in the loop comes out to be NE by NR. If you cancel out N and N both in numerator and denominator, you get the current in the loop to be E by R. Now what's important here is to understand the current in the loop is independent of the number of cells. Whether you take 5 cells or 6 cells or 10 cells, the current in the loop, if they are connected in the same polarity sense so that they are trying to drive the current in the same sense, the current comes out to be the EMF of one of the cell divided by internal resistance of one of the cell. Now the second part of question, what is the potential drop across each cell? Tell me kids, here each cell is getting discharged or charged. So sir, since the current comes out of positive and enters into negative for each cell is getting discharged. So as each cell is discharging, we can say that the potential drop across each cell has to be equals to E minus IR. So what is E? EMF. What is I? Current through that one cell, and R is its internal resistance. So substituting the value of I here, you get the potential drop to be equals to E minus E by R into R. And if you have got E minus E by R into R, the R get cancelled, so you get E minus E, which is 0. When I solved this question for the first time in my life, I solved it using KVL. The simple thought of KVL is that the net potential drop across the closed loop is 0. If I assume, let's say, across one of the cell, the potential drop is X, then due to symmetry, since all the cells are identical, then the potential drop across each cell has to be the same value, X, 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 X. And if I start from a point, go once around the loop, and write the overall potential drop, I will get X plus X plus X plus X plus X plus X plus X. How many times? N times. So the overall potential drop will be Nx. And this net potential drop across the whole loop has to be equals to 0. So Nx has to be equals to 0. So X has to be equals to 0. This means that the potential drop across each cell has to be 0. Now, before I do the third part, I am going to give you one management lesson. Let's say you are manager at organization X and you have got a competing organization Y. If your team have got 50 people working and their team has got 50 people working, it's always better to hire a person from your competitor rather than from somewhere else in the market. If you hire one more person from somewhere else in the market, you will have 51 people and they will have 50 people. But if you hire one person from their organization, still you will have 51 people, but they will have 49 people. So hiring one person from the competitor do not create a difference of one person in the team size. It creates a difference of two persons. Sir, why are you suddenly giving us management gyan? Because that's what this third question is all about. People think that when we reverse X cells, then we have got only n minus x cells trying to drive the current in one sense, right? So the equivalent EMF has to be n minus x into E, but that will be wrong because the other x cells which have been reversed, now they are trying to drive the current in opposite sense. So out of the total n cells, when you reverse x cells, the number of cells which are now trying to drive the current in the original sense is n minus x into E. But the other x cells are trying to drive current in the opposite sense. So the net EMF is not n minus x into E, it is n minus x into E in one sense minus xe in the other sense. So you get an equivalent EMF of n minus x into E minus xe, that becomes n minus 2x into E. So on reversing x cells, the effective number of cells do not drop by x, they drop by 2x. And that's something you need to understand. So telling you the same thing mathematically. So if the polarity of X cells is reversed, the number of cells which are trying to drive the current in the same sense now are n minus x. And the number of cells which are trying to drive current in opposite sense now are x. So the equivalent EMF of the circuit will be equals to n minus x into E minus x into E. And the current in the circuit has to be equals to this equivalent EMF upon the resistance of the circuit. Since all the internal resistances are still in series, the equivalent internal resistance will be NR. So you get I dash equals to n minus x into E, which are trying to drive in one sense, minus xe, which are trying to drive in other sense, divided by NR. So when you solve this particular part, you get in the numerator n minus 2x into E by NR. And that will be the current in the circuit. So now comes the most important part of this particular hour, that is combination of cells in parallel. And if you get this thing right, you will never have to use KVL. I promise you. So if you have got multiple cells in parallel, EMF E1, R1, E2, R2, EMF E3, internal resistance R3, then how to replace all these cells with a single cell? What has to be the E equivalent? What has to be the R equivalent? First of all, I will talk about R equivalent. Why? Because it's just like resistances in parallel. So you will replace all these resistances and place a single internal resistance, and you will say 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. You already remember this thing, right? Now how to find the E equivalent? Remember the formula of E equivalent? Replacing all these cells, I will place a single cell, and how much has to be the EMF of that cell? So we say that the equivalent EMF is given by E1 by R1 plus E2 by R2 plus E3 by R3. and so on multiplied by R equivalent. Once more, E1 by R1 plus E2 by R2 plus E3 by R3 and so on multiplied by R equivalent. So this is how you find the equivalent EMF of these multiple cells. So R equivalent same like resistances in parallel, and E equivalent as E1 by R1 plus E2 by R2 plus E3 by R3 into R equivalent. Okay. Now I will tell you some important points before I tell you why this is super duper good thing to remember, why it is so useful. So let's do some important points. First, find R equivalent. Then use it to find E equivalent. In the formula of E equivalent, I said that E1 by R1 plus E2 by R2 plus E3 by R3 and so on into R equivalent. So first, when you are combining multiple cells in parallel, better first of all find out R equivalent, because R equivalent will help you in finding out E equivalent. Second point, be cautious about the polarity of battery. In the question, they might flip the polarity of one of the cells. As you can see in this question, I have flipped the polarity of one of the cell of EMF E2. The E1 wants left hand side to be higher, the E3 wants left hand side to be higher, but this E2 guy wants right hand side to be higher. Now sir, what to do? Beta, same thing. When you find the equivalent of this, in R equivalent there is no change because resistances can't be treated as negative. But when you find out E equivalent, then be cautious to place a minus sign for E2. So you will say the E equivalent will be E1 by R1 minus E2 by R2 plus E3 by R3 into R equivalent. So this is something you have to be cautious. Be cautious about the polarity of battery. This is something I keep on saying again and again. If you just take care of polarity of battery and you know this parallel formula, most of the current electricity is already done. The next point is, if we have got n batteries of same EMF, the equivalent EMF also comes out to be same, given that they are in same polarity sense. So sir, what are you trying to say here? Let's say we have got multiple cell of 12 volt 5 ohm, 12 volt 6 ohm, 12 volt 10 ohm. No matter what the equivalent resistance comes out to be, if they are connected in same polarity sense, then the equivalent EMF will come out to be 12 volt. Try it out, check it that sir has said this point right or wrong. If you have got multiple cells of same EMF, then the equivalent EMF also comes out to be same, given that all of them are pointing in the same polarity sense. All of them want one side of the equivalent to be at higher potential. Then the equivalent EMF comes out to be same as 12 volt. Next, the fourth point is, if you have a grid and this grid has got m number of rows, and in each row, let's say you have got n number of cells, then how to find the equivalent EMF and equivalent resistance for this grid? So you have learned how to find the equivalent for a series combination. You will say, if I look only at one row, then there are n identical cells and all of them have got their EMF in the same polarity sense. So replacing all these individual cells, I can place only one cell using the series combination and say that in one line the equivalent EMF is NE and in one line the equivalent resistance is NR. So I can think of this whole grid to be same as in each line I have got an EMF of NE, equivalent resistance of NR, NE, NR, NE, NR. Now when I further try to combine all these parallel batteries, we have just learned that if the EMF of all the cells is same, then no matter what is the value of internal resistance, the equivalent EMF comes out to be same. So when you combine all of them into a single cell, then the equivalent EMF comes out to be NE, same as all of them, while the equivalent internal resistance comes out to be NR by M. Because we have learned, if we have got multiple resistances connected in parallel, let's say R, if you have got 3, the equivalent resistance is R by 3. If you have got 4, equivalent resistance is R by 4. So if you have got M identical internal resistances, NR, 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 NR connected in parallel, then the equivalent internal resistance has to be NR by M, right? So this is how we solve a grid. This is important, you should know this. Moving on. Use equivalent of cell rather than KVL whenever possible. Personally, I have never used KVL. This particular point is written here to put it in your mind that using the equivalent combination of cells is way better than using KVL to solve question. How? To understand this, we are going to now practice 5 questions based on this thing. In this question, you can see a circuit and the mission is to find I. In the circuit, you have got 3 cells and they have got 3 internal resistances. Our mission is to find I. The standard process taught to solve this type of question is to assume current in each branch and then to write 3 equations of KVL to get the 3 currents I1, I2 and I3. I tell students not to go by this method. If they have asked you current in the third branch, combine the first 2 branches using the parallel combination of cells. Once you have combined these 2 branches, you will get only one cell of having some E equivalent, having some R equivalent, and then you will have this third cell of EMF 4 volt and 2 ohm, and now this becomes a single loop problem. So how to do it? So beta, the process goes like combine these 2 cells. To combine the 2 cells, find out first their R equivalent. So if you have got 2 cells of resistance 6 and 3 in parallel, the R equivalent for 2 resistances in parallel can be written as R1 R2 upon R1 plus R2. So that will be 6 into 3 upon 6 plus 3, that will be 18 by 9, that will be 2. So replacing these 2, I can place a single resistance of 2. Now how to write the E equivalent? E equivalent will be E1 by R1 12 by 6 plus E2 by R2 12 by 3 into the R equivalent, which came out to be 2. So here you get 2 plus 4, which is 6 into 2. So the equivalent EMF comes out to be 12 volt. So R equivalent comes out to be 2 ohm and the E equivalent comes out to be 12 by 6 plus 12 by 3 multiplied by R equivalent, that comes out to be 12 volt. Notice here, I just told you, if both the cells have same EMF and they have got the same polarity sense, then the equivalent EMF comes out to be same, 12 volt. You don't even have to solve for this. Okay. Now once you have combined these 2, so do not think of them separately. Just think a single cell of EMF 12 volt and a single cell of internal resistance 2 ohm. Now tell me what will be the value of I. So you will say this 12 volt tries to drive current clockwise, while the 4 volt tries to drive current anti-clockwise. Who wins? Definitely the stronger one, the 12 volt. So the current in the loop, which is I, we need to find, has to be equals to 12 minus 4 upon the resistance of the single loop, which is 2 plus 2. So 12 minus 4 gives you 8, 8 by 4 gives you 2 ampere, so the value of I is 2 ampere. Now I'm going to do the same thing for more questions to practice. There are 4 more questions coming up. Listen very carefully. If they give you this type of circuit, now rather than asking the current in the last line, they have asked you current in this line. Then what to do, how to find I? So you will say, sir, these 3 are connected in parallel. Yes. If I move them around, it doesn't matter. So rethink of the circuit in your brain. Do not redraw, rethink. And think that rather than this 30 volt connected at the end, this is connected in between. I have just switched the parallel components against each other. So this one is same. I have switched to these 2 and moving the 5 volt to the side. My mission is to find the current flowing through this cell of 5 volt and 5 ohm, right? Now what I am going to do is I am going to combine these 2 using the parallel combination of cells. First of all, I will find out the R equivalent. So R equivalent of 10 and 10 gives you 10 into 10 by 10 plus 10, that is 20. So that comes out to be 5 ohm. Or you can say, if you have got 2 identical resistance of 10 and 10 in parallel, the R equivalent has to be 10 by 2, that has to be 5 ohm. Once you have found the R equivalent, now it's time to find the E equivalent. E equivalent will be E1 by R1 plus E2 by R2 into R equivalent. So that will be 20 by 10 plus 30 by 10 into 5. 20 by 10 gives you 2, 30 by 10 gives you 3, 2 plus 3 gives you 5, 5 into 5 gives you 25 volt. So rather than thinking of these 2 different cells, think of only one cell of EMF 25 volt and resistance 5 ohm. Now this is what the smaller single loop circuit looks like. So you have got a battery of 25 volt trying to drive current clockwise. You have got another battery of 5 volt also trying to drive current clockwise. So both of them are trying to drive current in the same sense. And the equivalent resistance is 5 plus 5. So the current will be equals to 25 plus 5 upon 5 plus 5, that comes out to be 30 by 10, that comes out to be 3 ampere. And this is how simply you can solve the question without using KVL. So if they ask you current in the last line, combine these two. If they ask you current in middle line, combine these two. If they ask you current in the first line, combine these two, right? Easy thing. Let's practice a little bit more. So revisualize the circuit. Rather than of thinking of 1 ohm and 3 ohm, I have placed only one resistance of 4 ohm. Rather than placing two batteries of 6 volt and 24 volt, I have placed only one battery of 30 volt. Rather than thinking of three resistance of 1, 4 and 1, I have thought of only one resistance of 6 ohm. Now since I need to find the current in the middle branch, in my mind only I will reswap them. So reswap them, but when you reswap, better keep the polarity of battery in mind. This 20 volt want upper side to be higher, this 30 volt want lower side to be higher, this 4 volt want lower side to be higher. So reswap them. Still 20 volt want upper side to be higher, 30 volt want lower side to be higher, 4 volt want lower side to be higher. And now you can combine these two cells to make a single loop. So when you try to combine them, you need to find two things, R equivalent and E equivalent. So you will say R equivalent will be equals to 4 into 6 upon 4 plus 6. So that will be 24 by 10 and that will be 2.4 ohm or 12 by 5 ohm. Now let's find out the E equivalent. When we find out E equivalent, we will write 20 by 4 plus 30 by 6 into R equivalent, right? No. Be very cautious about the polarity of batteries. These both batteries do not want the upper side to be higher. So here you won't write plus, you will write minus. So you will say E equivalent will be 20 by 4 minus 30 by 6 into 12 by 5. Now 20 by 4 gives you 5, 30 by 6 gives you 5, and beta 5 minus 5, this whole part becomes 0. So the equivalent EMF comes out to be 0 volt. Sir, if the equivalent EMF comes out to be 0 volt, what to do? You don't have a battery of any EMF. So the battery has only internal resistance. So this whole system acts like only having a resistance of 12 by 5 ohm. So now visualize the circuit. You just have one resistor of 12 by 5 ohm, a battery of 4 volt and one more resistance of 5 ohm. Question is, what will be the current in the circuit? So you will say current has to be the EMF divided by the resistance, which is 5 plus 12 by 5. So current comes out to be 4 upon 5 plus 12 by 5. Now you have got 4 upon 12 by 5 plus 5, that becomes 4 upon 12 plus 5 into 5, 25 by 5, that is 4 upon 12 plus 25, 37 by 5. The 5 moves from denominator to numerator, so you get 20 by 37. So the current on solving comes out to be same as 20 by 37. Now let's practice two more questions which will look even more weird than this one. If they give you a question something like this, now you need to find I again. Now here you do not have three straight rows. Now how to do this question? Better, these questions are easy. So think of three lines. This is one line, this is the second line, and this is the third line. In the first line, you have got two cells. 2 volt want A to be higher, 8 volt want B to be higher. So replace these two cells with only one cell of 6 volt which want B to be higher. And there is only one resistance of 6 ohm. Okay. Now in this central line, you have got only one cell, one resistance. Okay. In the third line, you have got two cells. 6 volt want B to be higher, 3 volt want B to be higher. So both of them want B to be higher. So replace these two cells with a single cell of 9 volt which want B to be higher. And for this upper line, replacing the two resistance of 1 ohm and 2 ohm, place a single resistance of 3 ohm as both of them are in series. So redraw the circuit, reimagine the circuit. Here between A and B, I have redrawn the whole circuit. This line of 2 volt 6 volt, replacing the two cells, I have placed only a single cell of 6 volt which want B to be higher. In place of this central line of 2 volt 2 ohm, I have placed only single cell of 2 volt and 2 ohm. Beta, when you redraw, be very cautious about the polarity of the batteries. This battery want which one higher? B higher. This battery want which one higher? B higher, right? Now, replacing these two cells, I have placed a single cell of 9 volt. And replacing these two resistors, I have placed a single resistor of 3 ohm. But while placing the cell, I was extra cautious that this 3 volt won't be higher, 6 volt won't be higher. So this 9 volt, the effective of 3 and 6 should want to be like be higher. Now our mission is to find the current in the third one. In the third line, the current is marked from B to A. So our mission is to find I, right? Our mission is to find I in the third line from B to A. What to do? So now we know you are going to combine these two. When you combine these two, what will be the R equivalent? 6 into 3 upon 6 plus 3, 18 by 9, which is 2 ohm. So you'll say R equivalent is 2 ohm. And what will be the E equivalent? Be cautious about polarity. Both of them want lower side B to be higher. So you will say E equivalent will be 6 by 6 plus 9 by 3 into the R equivalent, which is 2. 6 by 6 gives you 1, 9 by 3 gives you 3, 1 plus 3 gives you 4, 4 into 2 you get 8 volt. And this 8 volt has to be placed in the same way as 6 volt and 9 volt. That is, they want the potential of B to be higher. So replace these two cells and think of a single cell of 8 volt having an internal resistance of 2 ohm, and you have already got this circuit of 2 volt and 2 ohm. Your mission is to find I. How to find? Let's see. You will say this 8 volt want to drive current anti-clockwise, while this 2 volt want to drive current from its positive to its negative, that is clockwise. So you will say the value of I will be equals to 8 minus 2, which is 6, upon the equivalent resistance of the circuit, which is 2 plus 2, 4. So the current comes out to be 1.5 ampere. So now you see how helpful this particular thing of E equivalent is and how it can be used to solve even the most difficult of problems. So let's practice one more question before I say you tata bye bye today. So the question goes like, now we have got this circuit. It looks even uglier, but it is as simple as the one we have done till now. And your mission is again the same, find I. Now we will do the same process. In this line, one cell, one resistance, okay, fine. In the second line, the central line, we have got two resistances. So rather than writing 1 ohm and 2 ohm, we will write a single resistance of 3 ohm. And we have got one cell only of 4 volt, happy. In the upper line, we have got two cells. The 11 volt want B to be higher, while the 3 volt want A to be higher. So replacing these two cells of 11 and 3, we will place a single cell of 8 volt which want B to be higher. And rather than placing three resistance of 1, 2 and 1, I will place a single resistance of 4 ohm. So in your mind, first redraw the circuit. So here we have got a battery of 8 volt which want B to be higher. All these points will be at same potential A and all these points will be at same potential B, right? They are joined by a wire. Now replacing the upper line, replacing the two cells of 11 volt and 3 volt with a single cell of 8 volt which want B to be higher, and replacing these three resistance of 1, 2 and 1 with a single resistance of 4. And here in this third line, replacing the two resistance of 1 and 2 with a single resistance of 3, and replacing the battery is only single of 4 volt, so placing it as 4 volt. Beta again saying, while playing with batteries, be very cautious about the polarity. This 8 volt want B to be higher. See, 8 volt want B to be higher. This 11 and 3 combination of 8 volt want B to be higher. 8 volt want B to be higher. This 4 volt want A to be higher. So have been redrawn such that 4 volt want A to be higher. Now our mission is to find I. To find I, we will do the same thing. We will combine these two cells. Now combining these two is very easy. They have got the same EMF, so I don't even need to solve. I know that the equivalent EMF will be 8 volt which want B to be high. And the R equivalent of two identical resistances connected in parallel will be R by 2. So you will get 2 ohm. So the R equivalent comes out to be 2 ohm and E equivalent comes out to be 8 volt. Now replace these two with a single cell of 8 volt which want B to be higher and 2 ohm, and you have got one more 4 volt and 3 ohm. Now this 8 volt tries to drive current from its positive to negative, that is anti-clockwise. The 4 volt tries to drive current from its positive to its negative, that is anti-clockwise. Both of them try to drive the current in the same sense. So you will say I has to be equals to 8 plus 4 upon 2 plus 3. So 8 plus 4, 12 upon 2 plus 3, which is 5. So the current comes out to be 12 by 5 ampere. So That's all in this hour. In the next hour, we will talk about series parallel combination question of resistor and the most important thing, that is power. See you guys in next hour. Bye bye. So that's all for now. See you guys in the next hour.